Okay, again, this is Tom Wilder with the North Carolina Department of Labor. Glad to have everybody here today for our class. Again, this is Confined Space for General Industry. So, again, I'm Tom Wilder. Most of you know me, but for those of you who don't, I've been with the department about 7 years. Prior to that, I worked 28 years in various safety, training, and quality management positions in the textile, machine assembly, and pharmaceutical industries. Most of those years were in pharmaceutical manufacturing, from which I am now retired. And like before, I may be giving you some examples from my industry experience, because when I was in pharmaceuticals, we had several confined spaces on our site, and I can tell you a little bit about how we ran our program. So let's go ahead and go to logistics. If you're in an office, look around. If you have a door, close it. If you got phones, you might want to turn those off. If you're in a cubicle, hopefully you have headphones and put up a do not disturb note. We'll be using Webinato again today. You'll see the PowerPoint slides in the center of the screen. If you have a mobile device and don't see the PowerPoint slide, that's an issue with your device. So you might want to log on with a computer. Or if you can't hear my voice, and of course, if you can't hear my voice, you can't hear this, then you want to go to a computer as well. There's an emoji in the bottom left corner. I will not be using that. But there is a chat box at the bottom of the screen, which a lot of you have been using. Scroll down to the bottom of your screen, and that's where you'll type in your questions or comments. Also, as before, you must attend 80% of the course time to receive credit. I'll be checking that after the class today. And we cannot give credit to anybody who's not registered and logged in. If you have people sitting around you, I can only give credit to the people that are registered and logged in. You'll get a certificate probably within 3 weeks. If you don't get that certificate within about 3 weeks, give us a call. And our webinar is scheduled for an hour and a half, and regardless of time, you'll get an hour and a half credit, which you can use for obtaining and maintaining EHS certifications such as your mesh certification. So that's all my introduction and logistics. And let's go ahead and do my instant polls like I usually do. I want to do mine on your experience level, the confined space topic. So let's go ahead and let me know what's your experience level with this topic, confined space for general industry. Like I said, it's always good for me to know what your experience level is. And like I said, everybody was a beginner at one time, but I'm glad to see that we have a few beginners, but several intermediate folks out there as well. So, and we have about 18 people responding right now. So let me go ahead and stop that poll and close it. And I want to look at your professional safety experience to give me an idea. So how many years of professional safety experience do you have? Let's see how everybody falls here today. And I do know that I probably have some experts out there in the audience, and we learn from each other. I might learn something from you today. So feel free to share your examples or ask questions or make comments. That's what it's all about. It's all about all of us together today in class. Wow, boy, we have all kinds of diversity there. It's almost a bell curve. I got 4 beginners, 6 1 to 5, 6 5 to 10, and 2 greater than 10 of people responding. So thanks for responding to that poll for professional safety experience. So I'm going to stop that poll and close it. Now, one thing you know, if you have confined spaces on your work site, it is important for you to understand these OSHA requirements. Today's session covers general industry. If you are in construction, the relatively new construction standard is similar, but somewhat stricter. In the near future, we should be conducting construction confined space entry webinars and classes. So only a few years ago, the construction standard for a confined space was very simple, and it was performance-based, and a lot of people were still dying in construction confined spaces. So federal OSHA decided that it was time to get strict, and they came out with a more detailed, stricter confined space standard for construction. So stay tuned in the future, and we'll do that particular class. So today, if you are in the construction industry, a lot of these requirements we're going to cover today are also required in the construction standard, so it would not be a waste of your time. Okay, so I think we've got all the logistics done and the instant polls and my icebreaker. So let's go ahead and get started. So today we're going to identify confined spaces and talk about the difference between a permit space and a non-permit space. Determine if a hazard exists within the confined space, and if you have permit required confined spaces, you need to know the roles of the entrant, attendant, and entry supervisor and their responsibilities. So all your players there in a permit required confined space entry, they need to know their roles and have been trained. And if you have a permit space, you have to pre-plan for rescue, and we're going to talk about rescue options. I've got a couple of videos today. If I have time, I'll show them. We'll see how we do on time. So let's continue to the next slide. Now, of course, this standard, the general industry standard, contains the requirements for entry into permit required confined spaces, but it does not apply to agriculture, construction, or shipyards because they have their own standards. So right here, you see a manhole cover here, and it says it's very small, hard to read, but it says that it's a permit required confined space right there in the manhole cover. Now, many of you already know this, but a confined space is big enough for you to put your entire body in that space and do work. But it also has a limited or restricted ways to get in and out. It's like a manhole is not easy to get in and out of. There's usually a ladder built into the side if you go in, or you may have to insert a ladder. It's hard to get in and out. People typically don't work in manholes all day long. I mean, all year long. It's not designed for somebody to be in there every day of the year. And like the last bullet says, not designed for continuous occupancy. So it's big enough to get in, it's hard to get in and out of, and it's not meant to be a space to have somebody in there all the time. Now, most of you, or many of you, live in homes. Now, some of you may be in an apartment, but if you live in a house, what are two home examples of confined spaces? What are two home? Okay, Michael. Crawl space. And it could be under a trailer, like you say, or under a stick-built house. Attic and crawl spaces. Those are confined spaces. Now, if you hire a contractor, now if you have somebody putting in a new heating and air system, now that would get into the construction standard. They would be going into your confined space, and the construction standard would essentially make that person that's making the decision go in a competent person, and they have to decide whether it's safe to go in. But in an attic, like I said, we're not doing the construction standard today, but like I said, attic and crawl spaces are great examples of confined spaces. Now, whether you're if you work at a factory or any company, if you have similar types of confined spaces, are all confined spaces permit spaces? Do all confined spaces require a permit to go into them? No. That's right, Angie. Why is that? Why is there not a permit required? Why would you not need a permit? That's right, Angie, they're not all hazardous. So the thing that makes a confined space a permit space is all these three things that we've listed here, plus it either has a hazard or a potential hazard. And I would say reasonably anticipated potential hazard, reasonably anticipated. So that's what would make it a permit space. But regular confined spaces, some of these are permit spaces. They may or may not be permit spaces. Are you sending an employee into a tank, into a manhole sewer, into a grain storage bin, boilers, ducts, tank cars, vaults, sewers, again, vaults, pipelines, certain equipment and machinery, tunnels, open top spaces greater than 4 feet. Now, uh, if there's if you walked along a floor and you saw a big square area recessed into the floor that was 4 feet or deeper, and there's no way to get in and out of that space, automatically that would make it a confined space. If it's a permit space or not, that depends on whether there's any hazard or reasonably anticipated hazard in that space. Now, I want to give you an example, a common example of a permit required confined space that you may have at your workplace. Now, everybody out there, I don't care if you work for the government or private sector, you all have trash. And what kind of confined space that might require a permit would could there be? Now, a dumpster. Now, a dumpster is a good example of a confined space that might not necessarily be a permit space. And Stephanie, you're going right into what I'm looking for. Ashley, Muriel, Michael. Compactor. Now, many of the large industries that I've worked for, we all had trash compactors at the rear of the building or one of the docks. And you know, you'd put your trash in there and hit a button and it would compact that trash. Now, a trash compactor, if you just walk up to a trash compactor, is this electronic or that uses power, would that be a permit space? I mean, I'm just walking up to a trash compactor. I mean, I don't know whether I should get in there or not. Would that be a permit space? I'm looking for more answers. Nobody wants to say. Come on, be bold. I'm saying yes. I'm saying that yes, that trash compactor is a permit required confined space. But I'm talking about, Herb says not unless you enter, but I want somebody to know before they even think about going in or not. Let's say you work for a company and you have a trash compactor out back. It's connected to the building, and you don't have a secure site, and people can just walk up there all day long and walk around your building. Is it possible for somebody just to get in that compactor? Somebody. Is it possible? Of course, right, Angie. Inside the building, you may have a dock door down. When you hit that button, you don't know if somebody's in there or not. So if I'm a company, I have a trash compactor, I'm going to label it non-permit required confined space. Do not enter. Now we haven't got into the requirements yet, but is there a way to eliminate all the hazards from a trash compactor where somebody could go in there? Is there a way to eliminate the hazards before somebody goes in? Yes. Maybe there's a delay. Yes, there is. Now, lockout, tagout, David and Cheryl, you're right. If all it is let's say there's no possible atmospheric problem, it's going to be a case-by-case basis, and I think that's how Michael's thinking. But if you're absolutely sure that it's locked out, it could be a new compactor. It never had anything in it. You have to investigate. If you have other hazards, then you can't reclassify it. But lockout, tagout alone, if that eliminated all hazards, then that could be reclassified as a non-permanent space and entered without going through an entrant and a supervisor and an attendant and the form and all that. But if you can't eliminate the hazards completely, then you would be doing a permit required confined space entry. But if you have a trash compactor, the way I look at it, I would have that thing labeled permit required confined space, do not enter. If you can eliminate all those causes, then you can reclassify it just for that particular entry as a non-permit entry. Okay, so let's keep going. Now, permit spaces could have several hazards. Could a trash compactor have hazardous atmosphere inside there? Is that possible? Hazardous? Yes, absolutely. Does the space have inwardly converging walls or sloping floors? So you got things like tanks and grain bins where you can slide in, it gets narrower and narrower, or you can become entrapped, or you can be engulfed. If you're in a grain bin, you fall in there, it's like quicksand. You fall into the grain, you start moving around. That allows your body to go deeper and deeper in there, and the grain collapses around you, and you can't even breathe, and you die in there. So like a grain bin. Engulfment could be from water. When you enter the confined space, are there water pipes, or there pipes in there with water supply in there? They could break or for some reason open up and engulf the entrant. Or there are any other recognized serious safety or health hazard. Now we're going to talk about a lot of the different hazardous atmospheres, but there could be other hazards. You can have snakes in there. You can have moving parts in there. You can have electrical in there. So you need to know your stuff before you or somebody tries to go in there, because you don't want anybody to get hurt. Now, other hazards, not enough oxygen. Now, what percent oxygen? What would be considered low oxygen? How much oxygen? Less than what? This is for your advanced students. Yeah, actually, it's less than 19.5%. 19 is pretty close. So if this 19% is oxygen deficient. So you're not going to go in there. You're going to be doing an investigation. And Michael, that would be less than atmospheric, but there's a range. There's a little variability on your oxygen content in the atmosphere. So, if it's oxygen deficient, your employee could die in there from not having enough oxygen, or it could have too much oxygen. If there was too much oxygen in there, of course, that could be from some oxygen supply. What would that cause? Potentially, too much oxygen. What would that support? Too much oxygen. Combustion, right, or fire or an explosion. Okay, flammable atmospheres, toxic atmospheres, or the space. There's a lot of noise in there, or somebody can be trapped in there, or they can be engulfed by grain or sand or water or extreme low or extreme high temperatures, moving parts. We already talked about lockout, tagout there, and electrical. Now I'm going to tell you a quick story from my industrial experience. We had a confined space, a permit required confined space, and this maintenance worker was going to go into a manhole. Now, this particular entry, I personally was not involved in. I was not the supervisor, the attendant, or the entrant. I didn't write up the permit. I wasn't even there. But we had a near miss, and near misses can be pretty scary, and it was scary to us as well. We had a permit required confined space. We had somebody going in, one entrant. Everybody had been trained, and they knew what to do. The entrant was in a harness, and we had a winch on the outside. Everything was locked out as far as anything supplying that space, and the person didn't have to go too far underground. They were straight down. And what the person was going to do was going to work on some electrical contacts in the space, and this employee did not communicate the fact that they were taking a small bottle of solvent, spray solvent, into the space. He might have had it tucked in his jacket. He did not tell anybody. So he goes down into the space, got an attendant outside, we have a supervisor, we have an entry. We had already checked the atmosphere at 3 levels before we went in, and we had continuous monitoring. So he took a spray solvent in there and started spraying some de-energized electrical contacts. Now he was in a small confined space, and he used quite a bit of that spray to dry out these contacts. What do you think happened next? Okay, he's got a can of solvent. He sprays it, and then something happened. Now it didn't arc. We didn't have any electrical in there, no source of spark or arc. Good answer, but that was not possible. If I go in a small hole and I take a spray can in there, okay, yeah, it removed oxygen. So if you're doing a proper entry, what happened then? Your levels are, yes, Angie, that's correct. You have an alarm. So we have a 4-gas meter doing continuous monitoring. The alarm went off. Well, we were lucky on that day that the entrant did a self-rescue. In other words, he heard the alarm and got right out. The space wasn't very deep, and he got out very quickly. Now, we're not always that lucky, but he got out. Now, what the attendant would have done if he hadn't gotten right out, he or she, I believe it was a he, would have winched the entrant out, just reeled them in. But we had an alarm. We had a very important meeting after that because those were ideal H conditions. immediately dangerous to life and health, we could have had a fatality on our site. Okay, yeah, Michael, you deal with a lot on airplanes and the fuel cell. Okay, so even companies have good safety programs. One employee does something that's outside procedure, doesn't communicate, you can have a terrible accident. So again, we were lucky, and we don't want to base our safety program on luck. So we did quite a bit of retraining and training after that because it was an incident. We did an investigation. We did an incident report, whole bit. Okay, now let's go to the next slide. Now we want to eliminate our hazards or control them. You want to lock out moving parts, de-energize your electricity, block steam, blank steam pipes and in-feeding pipes, pump out liquid content. So if you're going underground and the space is full of water, we're not going to send somebody down there to work. We're going to pump that out. And we're going to monitor the air and ventilate the space. Now, because this was a permit required confined space entry, permit required confined space entry, we had to sample the air. So if you're a company that you're doing a permit space entry and you're checking the atmosphere, how many levels of monitoring are you going to do? Bottom, top, middle? How many levels? At least what? How many levels of monitoring are you going to do? I'm talking about how deep. Does anybody know? I know somebody must know. How many? Okay. The answer is 3. So if you're checking out a space prior to entry and you're following your permit and you get your meter and you check the atmosphere, you're going to check the top of the space, the middle of the space, and the bottom of the space. And you're going to give your air sampler time enough for the sample to get to the meter itself. Okay, you're going to do 3 levels of monitoring. All right, let's keep going. Now, we'll get back to the permit procedure in a few minutes. Now, this slide says if you have a workplace and it contains permit spaces, the employer should let everybody know by posting signs or any other equivalent and effective means. So if I go to your work site and I say, do you have a confined space program? Yes, we do. We have permit space. Are they all labeled? Yes, they are. Good. If their permit spaces were not labeled, we would have to interview every employee and say, can you name all the permit required confined spaces? Now, if it's a big site, I'm betting that they can't do that. So this says other equally effective means. So if you didn't mark them, everybody would have to know. I would not want to depend on that. And you would also have to have a controlled site where nobody else could get on your site. So not having a mark would not be a good idea. Okay? That's required right in the standard. Now, if you decide that all your employees will never enter these spaces, you've got to have a measure to keep all your employees from going in there. So, how would you? And now manholes aren't we can have HVAC units. You can have a lot of other places people could go. But how are you going to keep people out? How do you keep them out of a permit required confined space? How do you keep people out? Well, they'll let you all type in the answer. How do you keep people out of permit spaces? Okay, signage, locks and chains, and it depends on the space. It could have a door, lock the door, fences and locks. A lot of great ideas there. Barriers, great ideas, and it depends on the space. Now, sometimes with your manholes, those manhole covers are so heavy that it's not, you know, practically easy for people just to lift those manhole covers and go in. If they're easy to get into, I would take extra measures. If they're reasonably hard to not get in, you might not worry about it, but make sure they're all labeled. Okay. Now, I will tell you, if your whole site's not if your whole site's not secure, excuse me, then I want to take extra measures to keep other people out. I mean, you could have a factory that is beside a neighborhood and you have kids that come over and roam around your site. And a lot of kids will go places they're not supposed to go just because they don't have anything else to do. Now, if you're in a city, uh, what's a place that a kid would go that's a confined space? Kids do it all the time in a city. Kids would go in a city that's a confined. Yes, sewers, right. Could be sewers, right. But if you look at city streets, you'll have drainage pipe going under the streets. What do kids like to do? What do kids like to? Some kids, maybe not nowadays. They're probably they're too connected to their electronic devices now. But what do kids like to do? Explore. Um, have any of you in your life ever climbed through a drainage pipe or climbed or gone through a pipe under a street? I bet some of you have. And Stephanie, I'm glad you did. And Michael, and I've done it too, I have to admit, when I was a little kid. Now, this wasn't like a 2 foot diameter pipe. Some of that could get pretty scary. It was a bigger pipe, but I mean, I would never do that today. I mean, I would if somebody says, "Hey Tom, crawl under that street from one side to the other," I says, "No way, I'm going in there." But that would be a permit required confined space. Okay. Okay, Michael threw fireworks in it during the 4th of July. When you were in South Carolina, right, Michael? Just kidding. But anyway, keep people out of those permit spaces. Now, if you have permit spaces, you shall develop and implement a written permit space program. So you're going to have in your program, it's like a written program, you're going to have a form that your company, your authorized people are going to fill out every time somebody enters a permit required confined space. Now, let me tell you, your program is probably going to include several documents. They don't necessarily have to be in the same binder all together with a confined space entry program on the binder. But if you had an inspection, you would be asked to produce documentation that showed that you had a program and that you have control of safety of people entering these spaces. Now, what we did, we had a confined space in our factory years ago, pharmaceutical plant. We had a confined space written program, and we had all our confined spaces on the site listed, and then we had all of our permit required confined spaces listed. We had diagrams in our program of all the permit spaces. I mean, there were engineering drawings, and the engineering drawings would have isolation steps on there. It would talk about all the different energy sources or whatever you'd have to isolate before anybody would go in. Like I said, we'd have them all in there. We had all our training requirements. We had all that right there and with all that together in our program. So if you have people going into permit spaces, you need to have a program containing all the elements that we're getting ready to talk about, including the entry permit. So you're going to have measures and procedures. to keep your program, you're going to tell how you keep unauthorized people out, how you identify hazards, how do you keep people safe, what equipment do you use, and how do you use it, how do you evaluate conditions, how do you provide for at least one attendant, and how do you monitor. It says monitoring multiple spaces. The standard does allow an attendant to monitor multiple spaces, but they'd have to be right beside each other. I've never worked anywhere that had that situation. You would have to have an ideal situation to have one attendant monitoring two spaces at the same time. They'd have to be right beside each other. Now, let's go ahead and go to the next slide. How do you determine who does what? You're going to train your attendants, your supervisors, your entrants. How do you summons rescue? And we're going to spend a bit of time on rescue. How do you prepare, issue, use, and cancel permits? If you have a supervisor that issues a permit, they may cancel it because it's outside and a rainstorm develops, a storm develops, some conditions change. How do you conclude entry? How do you coordinate with other employers? You may have contractors working with you. And how do you review your program annually to make sure it's current and nothing has changed? So, with your confined spaces, you could have spaces that never require a permit. Those are just your regular old confined spaces, and there's nothing in the world that could develop to make them into a permit space. Or you could have spaces that all you'd have to do is ventilate those spaces, and you would not have any other hazards, and you would not have to use a permit. Or you have spaces that have more than one hazard, and that would require a permit system. Now, I will tell you, when I was in industry, I worked in a best practice facility. I mean, I worked for two companies that were Carolina Star, and anytime we sent somebody underground, we never reclassified any of those as non-permanent spaces because too many things can happen underground, too many variables. We could have gotten by with reclassifying some of them sometimes and just do ventilation only, but anytime we went underground, we said we're doing a permit every time to be safer. Now, if you do alternate or entries, and your employees have to be trained, you have to test your atmosphere, you have to use forced air ventilation, and of course, if you ever detect a hazardous atmosphere, of course, you must stop the entry. So that's your alternate entry. Now, this will be a little bit easier to understand if you look at the flow diagram that we're getting ready to go into. Here in a few minutes, we'll get to it. Your permit system, you're going to have a written procedure for how you do it. And you've got to make sure your document's properly completed, that it's there at the site, it's available, that the supervisor signs it. You've determined your job duration. And those permits that you issue for permit entries, they must be reviewed within a year to make sure that they're still good, that the spaces have not changed in any way. So when you have somebody entering one of these spaces under a permit, it's got to have a place for what is the space, why are we going in here, when and how long is the person in there, who are the authorized and trained entrants, who is the attendant, who is the supervisor. Now, go ahead and ask you a question. Can an attendant be a supervisor and an attendant, or do you have to have two separate people? This is really a good question. I'll wait for some more answers. Actually, the answer is yes. You can. Um, you can have a situation where the attendant is also trained and authorized to be the supervisor. Now, where I worked, we had separate attendant and supervisor, but the standard does allow, if they're properly trained, to have the attendant be the supervisor as well. The permit's going to talk about the hazards within the space that you've addressed, how you keep the space isolated, and what the acceptable conditions are. Well, good, Michael. And that's fine, Michael. I mean, a great answer would be two. I mean, ideally you would have two separate people, but there are situations where it's acceptable and safe to have the attendant be the supervisor, have both roles. But when I was in industry, essentially our maintenance folks would be the ones that went into the spaces, and the maintenance supervisor, who was a supervisor anyway, was the confined space entry supervisor, and they were all trained. Okay, now your permit's going to have your results from your air monitoring. It's going to specify what safety equipment you're going to have on site. How do you control the hazards? How do you communicate? There are a lot of different ways you can communicate. You don't necessarily have to have radios. Some people use ropes. They use knocking, or they may have direct voice communication. There are a lot of ways to do that. And your permit's going to have the rescue and emergency services information on there. Now, this is where you really need to be careful. And this is why a lot of people die in confined spaces. You'll have a good company, they just don't know any better. They'll create a confined space entry program, and in their program they don't do rescue. And what do you think's on their permit for rescue? This is not a good company. What's on their permit? Fire department, right, David. They'll put in an emergency call 911 or the fire department. Do you think in most cases, now let's just talk about hazardous atmosphere, do you think most of the cases the fire department can get there fast enough? What do you think about the response times? No, that's exactly right. So what happens, let's just play worst case situation. The fire department responds, and instead of having one victim, they've got three. They had two people try to rescue, and they got three bodies at the bottom of the space, and it becomes a recovery operation. So let's see. Now let's go back. Let's go back to this slide. Now what I want to do right now is I want to show you a video. Now this video is from WorkSafe BC. It's from Canada. They're great videos. We all have rights to show those videos. And let me show you a video on confined space rescue. Now, if you cannot see the video, it's because of your device, your computer, your mobile device. Some of you will not be able to see it and hear it. Some of you will hear it, and some of you will be able to see it and hear it. So I'm going to put video running, and I'll put please stand by. Stand by. So let's watch a video. So let me get that going and start the video player. And let's look at rescue. Here we go.
It happened in a vat at a winery in the Okanagan, in a shed at a mine in Kimberley, and in the rusty hold of a barge in New Westminster. Each time, workers died when they entered a confined space with not enough oxygen to breathe. Even worse, rescuers who tried to save them also perished. Incredibly, about 6 out of every 10 people who die in confined spaces are would-be rescuers. This sobering reality means that for any work around a confined space, there has to be a rescue plan that's tested and ready in advance.
The rescue from a confined space is, in most cases, a body recovery. You're going in to pick up somebody who has died as a consequence of an exposure to a toxic atmosphere or low oxygen. It's a real problem.
Can you hear me? Can you move your feet? I can see a foot. Can you wiggle it for me? Try and move that foot a bit. Okay, patient's unresponsive. Rescue 1, let's get ready to go. Rescue 1, ready to go.
If you follow the procedures, you have a proper confined space entry program. You do hazard identification and risk assessments. You know, you look at what the job function is going to be, what you're doing in the space. Are you going to create any airborne contaminants? And you know, you have an atmospheric monitoring program in place. You have a lockout and isolation program in place. If you do all those things to mitigate the hazard to the worker, you probably shouldn't end up putting a worker in a potential rescue situation. But you always have the medical component. Somebody has a heart attack or a medical problem within that space. How are you going to get them out of that space? And who's going to do it?
Most modern fire and rescue departments have some technical rescue capability, a skill that requires constant training and practice. That being said, industry must take responsibility for assessing risk and preparing to deal with it.
Industry used to say, well, we'll call 911 if the event, some jurisdictions, some municipalities don't have that capacity. Some fire departments are small and they don't have a confined space rescue capability within their department, so just calling 911, it doesn't cut it anymore for a rescue plan. We train right now. Last year our team documented 5,400 man hours of training for that year. The key point is competency. Is that team capable, equipped, and able to perform a rescue? And a rescue doesn't mean that you have a tripod sitting here and you got a winch. It means, you know, you need to have a plan in place, and you need to practice that plan, and that you can actually extricate somebody out of that space.
Human nature is such that we assume things are reliable and predictable, but when it comes to working in a confined space, the dangers are often invisible. Response time is critical, but so is ability.
The path to hell is paved with good intentions, and these people go in and they try and rescue, and they end up being victims themselves.
Okay. Now, go ahead and tell me, how many of you could see and hear the video? Could you see and hear the video? Good, good. Well, this is great for the people that could see and hear it. For the people that couldn't, I apologize. But that's a great video from WorkSafe BC that I did want to show. Excellent. So, let's see. Let's go ahead and, okay, Daniel, yours froze. Okay. Let me go into air monitoring. Now, you could have a potentially hazardous atmosphere in the space, especially when you go underground. But it could be in tanks, it could be in other spaces as well. So you've got lighter than air gases. So if you're doing 3 levels of monitoring, you're going to pick up your methanes near the top of the space. Your lighter than air gases are going to go to the top, and your heavier than air gases are going to go to the bottom. So like gasoline vapors are heavier than air, they'll go to the bottom. Methane will go to the top. So you see ammonia, carbon monoxide, nitrogen is almost the same as air. Then you got air, hydrogen sulfide, sewer gas. You know, you can have hydrogen sulfide. You have your rotten egg. Carbon dioxide is heavier. Gasoline, of course, and jet fuel. Now, what could introduce carbon monoxide to a confined space? What could introduce carbon monoxide to the space? Right, a combustion engine. Or, like I said, if it was outside, if the attendant allowed, like Herb says, a car exhaust, if they let a car or vehicle come by the space and stop with the exhaust right there at the space, it could be dumping carbon monoxide into the space as well. Somebody running a generator near a space. Carbon monoxide, of course, very deadly. Let's see, hydrogen sulfide, like I said, sewer gas, you can get that. carbon dioxide. We have had fatalities in North Carolina and nationally from carbon dioxide. And a lot of that is created by organic matter, or you can have chemical reactions that occur in the space underground. There have been some cases of carbon dioxide killing people, not monoxide. Now, if you've got a 4-gas meter that you're checking the air and the space with, does my 4-gas in the air and the space with, does my 4-gas meter have a sensor for carbon dioxide? What do you think? Most 4-gas meters, are you going to see a reading for carbon dioxide? What do you think? Most 4-gas meters. No, you're exactly right. Your 4-gas meters, and you can get sensors, you can get sensors depending on what your anticipated chemicals are or gases, but your standard meter is going to check oxygen, carbon monoxide, lower explosive limit, and hydrogen sulfide. That's your standard 4-gas meter. So if I'm taking readings and there's a carbon dioxide issue in the space, what reading is going to be affected? That's right, David. You're going to get low oxygen. So if you're getting low oxygen, you need to investigate. So that would be a clue, is low oxygen. Now, these 4-gas or however many gas meters you're using, your meters that you're measuring the atmosphere with, what are the 2 requirements for that meter? 2 requirements every time for that meter. What about these meters? Okay, intrinsically safe. Yep, that's a good answer. Okay. Okay, let's get a little bit broader than what it's checking for. Oxygen LEL, okay, that's good. Calibration, right. The meter has to be calibrated against standard gas. And of course, they would have alarms. That's correct. So you're going to have a calibration. And what are you going to have to do every time before use? It's calibrated. Bump test. That's right, Stephanie and Cheryl. You have to do a bump check before you do it. So your meter has a standard method and equipment, whatever you use for that meter, to bump test it against standard gases. So you're going to make sure you calibrate it to make sure it's accurate. And you're going to bump test it to make sure that it works correctly. And you're going to set your meter up when you're getting ready to use it against fresh air. You don't want to let your meter set up against contaminated air. So that's some things that you need to do. Now, let me go ahead. I'm going to go ahead and show you another video. Let's go ahead. Whoa, that's the wrong thing. Excuse me. That's me. Hello. Wrong tab. Let's go to, sorry about that. Let's go to our other confined space video. And this talks about hazardous atmospheres.
What I hear from those workers lucky enough to survive is that wherever they were working, they were fine one minute and unconscious the next. The human body is like a sponge for gases. And it doesn't matter how big or strong you are. And in many accidents, when a passerby has the presence of mind to phone for help, it's usually too late. So planning on being rescued is obviously not the solution.
What can be done to prevent these accidents and injuries? Well, it's really quite simple. You develop a standard set of procedures which you follow, and you provide education and training for the workers. Here are the basic principles which you must follow before working in any confined space. The procedures for your particular workplace will be more detailed. Before entering any confined space, ensure that the surrounding area is free from hazards. Test the atmosphere before you enter a confined space. It's essential that you take samples at various levels throughout the space. The first test to conduct is for oxygen. Oxygen deficiency can occur at any level. Some gases, such as hydrogen sulfide, are heavier than air and could settle on the bottom of the confined space. Methane will displace oxygen. It is an explosive gas and is lighter than air. Carbon monoxide has about the same weight as air, so it can be evenly distributed throughout the space. It's an asphyxiant, which prevents your body from absorbing oxygen, causing you to suffocate. Ensure that the tests are taken by a trained worker, and the results are recorded in a logbook or on an entry permit. If gas levels are unsafe, you must first ventilate and then retest before entering. If the gas levels are within safe limits, you must still ventilate the space before entering. Never use the ventilator like a vacuum to draw air out of the confined space. It may draw in toxic gases from other parts of the space. The fan must blow fresh air into the space. Ventilation will provide a continuous supply of fresh air and prevent the buildup of contaminants. While workers are in the confined space, ensure that there is a worker on watch who can summon a rescue crew in case of emergency, or is capable and equipped to conduct a rescue. Depending on the hazardous nature of the work or type of confined space, more sophisticated equipment and procedures may need to be used. For instance, workers may need to use a harness or lifeline attached to a tripod and wear a continuous gas monitor. There are even situations where a worker may have to wear a self-contained breathing apparatus. In summary, ensure the surrounding area is free of hazards. Test the atmosphere inside the confined space. Ventilate the confined space. And finally, ensure that a man watch has been initiated and emergency procedures have been established. Confined spaces can be found on many work sites, but their hazards may not be obvious. Preparation and testing are your only defenses against this potential killer. The danger is real, but by following established work procedures, most confined space tragedies can be prevented.
Okay, let's go back to the slides. And hopefully most of you could see and hear that video. Now, you can see there are several different types of confined spaces. It could be a tank, like a water tank. It could be underground. We talked about ventilation. And we talked about the different roles. The entrant is the person that goes in. The attendant is the person that monitors. And the entry supervisor that plans, authorizes, and terminates the entry. Now, you can train people for several roles, but don't put them in a role where they're not trained and qualified. Those are the duties. The person that goes in, they need to know the hazards that have been eliminated or potential hazards that could develop, proper use of their equipment, how they're going to communicate, when do you alert the attendant, and when to get out. The attendants, the person outside, they know the hazards or potential hazards, and they know the kind of behavioral effects that could be impacting the entrant if they start slurring their speech or starting sounding drowsy or something, They would know to do something. They need to keep a count and a log of who's in the space. They just need to stay outside the space the whole time. They need to communicate with the entrance, uh, constantly. They need to monitor everything. They need to keep people away from the space. You may have to set up barricades, those sorts of things around the space to keep people and vehicles away. And if they're not going to be doing the rescue, they need to be the one that summons rescue. Now, sometimes the attendant, if it's a simple space, will have a winch, and they'll do non-entry rescue. They'll essentially winch the victim out. But can an attendant ever go into the space? It's almost like a trick question. Can an attendant ever go in? They can't go in unless if he is replaced. Okay, if you have a situation where the attendant might go in, they have to be relieved before they go in. Are they going in as an entrant during the normal entry? Are they going in to rescue? In any case, the attendant has to be relieved. Now, normally you wouldn't have the attendant go in, but you need to pre-plan. If the attendant never supposed to go in, you're not going to tell them not to go in there. Now, we used a manhole example. It could be a tank. It could be somebody inside of an HVAC unit on top of a building. It could be a vault. But we'll use the manhole example because it's pretty easy to understand. If I'm coming up on a confined space entry, permit entry, and I see an attendant, what should I never see that attendant do? Never. Never. Yeah, smoking, leaving the area, walking away. Be on the phone. Leave his or her spot. Right. Now, if they're on the phone, it better be as part of the procedure as far as an emergency contacting somebody. But they should be attentive because the person's life that's inside that space is depending on this attendant. So that's a pretty important role. So they're going to take action when somebody comes up and approaches the space. Hey, stay away. We're doing a confined space entry. This is, we're not doing a show for people to see things. Stay out of this area. They may perform non-entry rescues, like if they have a winch, and they're not going to do anything that's going to interfere with their duties, like being on the cell phone. The supervisors, they need to know the hazards. They need to know that the permit is complete. He needs to, or she, needs to terminate and cancel the permit as required. Now, eventually, the entry is going to be finished, and the permit is going to be closed. That would be the supervisor. And the supervisor may decide to terminate an entry, let's say if it's outside and a storm comes up, for example. Now, rescue services, they better be close and nearby. And I'm going to tell you right now, in my opinion, that calling 911 is never going to be proper rescue because you're never going to have the response times quick enough if you've got bad atmosphere to rescue somebody. It's just not going to happen. So if you have the fire department as your rescue, not only should they be there on site, but they have to train with you. When you do your training, they have to train with you. And all your people that are involved, they have to be trained every year. And this isn't just watching a PowerPoint slide show. This is hands-on training. So when we did our training, we would do it at our spaces. Okay, we would, ahead of time, we would do our training. And the OSHA standard requires training on rescue at least once a year. So we would do retraining on everything every year to cover our rescue annual training requirement and just to keep people fresh on the material. But again, if you have people off site responding, I would recommend that you change your procedures. You would have to really prove that that the response time would not be critical. And in a lot of these situations, your response time is very critical to save somebody's life. Okay, you're going to train the people before they are assigned to duties, and before their duties change, when your operations change, and you're going to see if they're proficient in what they do. You know, if they're doing something, they may not be doing it right. Well, you're going to correct that while they're being trained to make sure they're proficient in doing what they do. I mean, whoever's doing the air sampling, they better know how to use the four-gas meter properly. They've got to remember to bump test it. People have to be trained to calibrate the meter. Your training documents, you need a certification of training. And what that means, it doesn't mean that they have to have a certificate that they put on the wall. That's not what certification means. Certification means a signed, legally certified training document. Certification is signature, signed training documentation, certification of training. Now, rescue, you can have different types of rescue. Use your own people or your own emergency services. Use your own employees to go into rescue, or non-entry rescue, like if you have a winch outside where you're going to retrieve somebody, that would be a non-entry rescue. You may use rescue services. Sometimes you can contract this out. But again, they need to participate in your training. If you're using a rescue service, there's an annual training requirement for rescue. They need to be involved. So your in-house people, again, need to be trained for rescue. They need to be trained in first aid CPR, and again, practice rescue at least annually. If they're using respirators, then you get into all your respirator training. Now, we have covered a lot to this point, and I should have stopped way before now. How's everybody doing? Do you have any comments, questions, or are we good to go? Okay, Angie's good, Michael's good, Ashley, everybody's good. Fantastic. And I hope you are learning something. And please, you know, type in at any time. I try to watch the chat. And after the webinar, if I miss something in the chat, I'll respond to the whole class. But I think I've been able to keep up with the chat pretty well. Now, if you got a non-entry rescue and you're able to use a winch, then they're going to use, the person going in is you're going to use a harness, and you're going to connect to the D-ring on the back of the harness, or the harness may have a couple of upper rings. You're going to connect to the point which allows you to pull them out of this spot. If the hole's too small, you may use other upper attachment points on your harness. It depends on what kind of space it is. And David says that our sound is dropping out. How's my sound doing? I got to go ahead and ask. Okay, Ashley says good. Okay. I want to make sure sound's okay. Very good. All right, let's go to the next slide. And the next slide goes into the appendices. The decision flow chart, procedures for testing the atmosphere, examples, permits, sewer system entries, and rescue evaluation criteria. Those are the appendices. Now, I really wish that this was really gigantic on your screen, but it's not. Even if you can see the full PowerPoint slide, you may not be able to read that. But if you've never seen Appendix A, after the webinar, unless you have the standard book right in front of you, go through the flow diagram on confined space entry and go through all the decision points and make sure you understand everything on that flow diagram. If you understand that flow diagram, you probably have a pretty good understanding on the OSHA requirements and what you need to do. So go to Appendix A when you can and go through that flow diagram to make sure you understand that diagram. If you have any questions about confined space entry, of course, you can call in to our main number and talk to our standards officers that are on duty every day, or you can send an email question into ask.osh@labor.nc.gov. Okay, let's go to the next slide. Now we've already talked about a lot of different types of confined spaces that you see here on this slide. Is this a confined space? Yes, it's a confined space. Would it be a permit space? I'm saying yes, it would be a permit space. We got inwardly converged. It's a tank. We got inwardly converging walls, and I would imagine if I could see the inside there, there are pipes and different things in the bottom there where somebody could become entrapped. So that's clearly confined space and a permit space. And we're going to go ahead and say, yes, this is a confined space and a permit space. Anytime you send somebody underground, you always have potential conditions that are either there or could develop. And this one is too. Now, all you see is doors there. That's actually a vault. So that goes below ground level. That's a vault again. It would be a confined space. And we'd have to evaluate that one to see whether it's a permit space or not, or whether ventilation with air would be the only problem. If you could ventilate it, you would be able to reclassify it as a non-permit space, possibly. Now this is a little diagram that Robert O'Neill drew, and it's showing HVAC units. Now HVAC units, this might be on the roof of a building or near the roof of a building. And you got moving parts, you got fans, you got little spaces people aren't supposed to be in. These units have doors on them. They're moving parts. Those units would clearly be a permit required confined space. So look at your HVAC units. You may need to put signage and labeling on those and have those in your procedures as well. That's a HVAC unit or two units beside each other. Okay, we got underground. This is fiber. You're going underground. There's fiber optic cable. And not only you have to check to make sure that that's safe, I would treat that as a permit required confined space and go from there. But we'd have to do some assessment of that space. And also a good rule of thumb, don't ever cut a fiber optic cable. If you want to be liable for bunches of money, fiber optic cable would be like the most expensive thing you could cut. It has huge impact. Okay, is this a confined space? Yes, it is. Of course it is. Again, so it's not always your underground spaces. Now this is this looks to be like a dust collector. This is a confined space, and it would be a permit space. You got moving parts, and believe it or not, people have to go inside of there to do service. And believe it or not, people have to go inside of there to do service. This is a confined space. It clearly is. It's a tank, inwardly converging walls. Again, a confined space. Now some of these, I mean, if you make the opening smaller and smaller and smaller, then you would ask, I mean, can a person even get in there? Oh, let me go ahead and ask a question that we usually get in webinars. Let's say you send somebody into a confined space, like a manhole. If a person walks up and sticks any part of their body in that manhole, is that a confined space entry? Go ahead and answer. If a person sticks any part of their body into that space, is that considered to be a confined space entry? The answer is yes. I don't care what's going on. If you've got a permit space and somebody breaks the plane of that space with their hand, their head, anything, that's an entry. Because guess what? You could open up a manhole, just a regular day, open up a manhole, stick your head in. What could happen after you stick your head in? Fall in. Or you could be overcome by gas. You could be overcome by gas and then fall in. So if somebody says, are they doing a confined space entry? I see that's a permit space. They say, well, no, they're not putting their whole body in there. No. If their whole body could go in there, if there's any part of their body that goes in, that's considered to be a confined space entry. Again, a confined space, this could be taken off. Somebody could go in there. That would be a permit space. So today, we've talked, of course, a lot about confined spaces and the difference between a confined space and a permit space, and about hazards and the responsibilities for the people that go in, that watch over the space and supervise, and the rescue options. It's now 11:17 a.m. and I'm going to go ahead and call that the end of the webinar. So thank you very much for being on our webinar today, and I will stay on here a few more minutes in case you have any questions. Thank you, Stephanie, Will, Ashley, Erica. Y'all have been great today. Michael. Yeah, hopefully everybody learned one thing or more. David, Robert, and Joseph. David, Michael. Yeah, all of you stay dry. So for those of you that are in North Carolina, sometimes we have out-of-state students, and we got a forecast for 3 days of rain this weekend. So a lot of us are going to have cabin fever this weekend. So maybe you'll watch movies or do something inside, but everybody stay dry. Avanda, you have a great holiday as well. So right now I've got 11:18. Oh, okay. Reclassifying permit required confined space. Okay, let's take one question at a time. Okay, are you talking about, it sounds like you're talking about, you've got a space you've been calling permit required. If there are no hazards and you have data and proof to show that we've been treating this as a permit space, that we've been assessing the atmosphere and the hazards all along, we have records and data, you can formally reclassify that space as a non-permit space. Is that what you're talking about? Okay. Let me go back. Okay. So you're talking about the solid waste trucks. Okay. Well, your solid waste trucks, I guess the fact, I mean, unless they're brand new, that they can't have waste in there. Well, those solid waste trucks are they're like tanks. They're like cylinders, right? And they have converging walls. Now they're of course always going to be a confined space, But the fact that you got solid waste in there, you can have variability because that waste could produce carbon dioxide if it's breaking down. The, all the different possibilities for different types of waste being in there. I don't think, in my opinion, we could ever permanently reclassify that. Okay. Okay, we've developed lockout, tagout procedures and done atmospheric testing, both full and empty. I mean, if the type of waste it has is always the same thing, and you could prove that there would never be any other type of waste that could generate hazardous atmosphere in there, you might be okay. What I would do on that one, now you've got consultative services involved. I would talk, if you've got somebody you've been working with, I'd work more with them. I go back to those consultative folks and work more with them. And you need to try to reach consensus with them. We do have standards officers here that are on duty. You can send in questions to ask.osh@labor.nc.gov. Send a formal question in. But I would involve those consultative folks and try to reach some consensus on it. That's about all I can say right now. Okay, now, I may have another question. Let me look. Okay. Cheryl asked, is there any expanded guidance on what constitutes a limited or restricted entry? Limited or restricted. Cheryl, I don't have any expanded guidance on that. Now, the fact that these spaces are covered by standard, we do have restrictions on people thinking about going into confined spaces. Once they've been classified as permit spaces, there is officially restricted entry on those. Limited entry, I'm not sure about that. Expanded guidance on restricted entry. I don't know. I don't know any more than what I've just told you. So what I would do, Federal OSHA has a lot of information. You might have to do some research, but I only know about the restrictions they're put in there by the standard. Okay. All right. You're welcome. Okay. Well, it looks like we had a couple of questions. If you want to go further with those, call in and talk to our standards officers or talk to your consultative people. And it is now 11:23. I'm going to go ahead and call that the end of the webinar. So thank all of you for being online today, and I'm going to go ahead and stop the webinar. So everybody have a good rest of your Thursday and a great Friday and weekend. And we will see you later. Bye-bye.